Welcome to this video where we troubleshoot and repair a Sega Gremlin Carnival game board, specifically the extended ROM logic board.
Okay, so we're back trying to fix this Sega Gremlin board here, and the next step that we're at is testing the RAM. So the RAM, and I'm going to tell you, I'm pretty sure it's already not the RAM, although we got to test the RAM anyway, especially on these boards, because even if it was the RAM, I should be getting something on that video. I think there's something wrong with the video circuit, but this is the next step, and you got to follow, unless you see something that you know the problem is, just follow the steps. That's the easiest way. So we're going to do RAM long 8000 to 8FFF. And if you'd want, you can do a RAM short first. I always do a RAM long, though, before I'm done, so I might as well do this. And hit enter. And we'll wait. So now, it showed up okay. So the next thing to test is the ROMs.
Now, the next step is to test the ROMs. And there are 16 ROMs, and just to save time, because this is already a long video, I'm going to tell you I already did them, because I did. And they all checked out fine. So we'll move on from there.
Now, I'm not getting any video here. So I want to go back from the video circuits and see what happens. If I look at the video signals, let's see if you can see this on the board. Watch the Oscilloscope. You're going to see really nothing. Right? Just noise. We do have a valid sync signal, but the color signals are nothing. So let's go back and look on the schematics. And this board, I've only been able to find the schematics. This look like a photocopy of some really old schematics, but they work for this specific model of the board. So what we have here is we have green, blue, and red. They go through a resistor. We're not going to worry about that. U67 pins 4, 7, and 9, and input pins 3, 6, and 10. Okay. So let's probe out the outputs. We already actually know the outputs are nothing, but we're going to probe them out, and then we're going to probe out the inputs, because you always want to make sure, just because your output is not bad doesn't mean the chip is bad, because if the chip's input is bad, it's probably not that chip. It's probably something else earlier in the circuit. So U67. We're going through pin 4, 1, 2, 3, 4, nothing. Pin 7, 5, 6, 7, nothing. And 9, nothing. And our inputs, we have it could be two sets of inputs that drive this. 3, 6, and 10. Nothing. Actually, it's floating, which is odd. It's floating. 4, 5, 6. That's ground. And we have 10. 10. Ground. And that's interesting that the one is floating. 1, 2, 3, 4, 5, 6. Oh no, it's ground. I just must have had my must not have been on it. Okay, so outputs are all basically ground, and so are the inputs. So that doesn't tell us anything. There's also an input 15. I believe that's a select, chip select. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now that is interesting because that is floating. That should be either ground or high. That should not be neither. So that usually when you get a floating chip, that's a bad. That's actually a good sign that whatever's driving that is bad, because you should almost never be floating. That's not 100% the case. If you have something called a high impedance output, that means the chip is basically disabled. Then that will be floating. That's actually designed because you do not want to affect the circuit at all when you're in high impedance mode. So, but this should not be floating. That should never be floating. Okay, that should be either high or low. So we track back 15. 15 looks like it comes from U65, which is a 74, 74. And the outputs are 9 and 8. And they should be the opposite of each other. With this chip, output 9 is the signal and output 8 is the opposite of the signal. So one way to test this chip, the 74, is to make sure they're actually both in they're opposite of each other. And you can do that with an oscilloscope very easily. You only need one channel too, generally speaking. So we got outputs 9 and 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's floating, and that's not right. And 8 is also floating. So that's definitely something that's not right. Because those inputs should not be floating. They should be output each other, the opposite of each other. They're both floating. So I'm going to pull this chip and see what changes, if anything changes. Oh, I want to also see the inputs too. I mean, the fact that it's floating outputs should not happen. So that's already a sign. Just for fun though, I want to see the inputs. Okay, we have valid inputs on that one, 12 and 11. Ground and some type of signal. So this chip has valid inputs and its outputs are both not valid. They should be the opposite of each other and neither of them should be floating. So we're going to pull that chip. And then we're going to put that chip in my chip tester. And you see we do have an error. So we're going to go ahead and replace that. So now we've taken that chip, put a new one in, and I still have nothing on my display. But I have some different signals. Pin 8 and 9 should be opposite of each other. 1, 2, 3, 4, 5, 6, 7. Right now I'm on pin 8, and now I'm on pin 9. They are the same exact signal. That is not the correct behavior for this chip. They should both be opposites. Now, what does that mean? Well, it means I could have a short circuit somewhere, pulling one of these high, but then I would have seen that probably, it wouldn't have been floating before. So my guess is that the chip it's going to is actually pulling it, maybe the chip it's going to is actually broken. So we're going to go ahead and take it off and see if that is actually the problem. If the chip it's going to is faulty and causing it to appear that this chip is putting out the wrong signal. What I'm doing is I actually took the chip that I think might be pulling it high off. Okay, let's go over here. It's this chip right here. And I'm going to actually test to see if this chip is outputting correctly now that this chip is gone. Because if this chip is gone and if this was the bad one, the outputs will be correct. I still won't have anything on my screen, but the outputs will be correct. So that's just one quick method I can use to test. So I'm going to go ahead and do that now and see if my outputs are correct on the chip I just replaced. So let's do that. So pin 8 is high, pin 9 is high. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so something is not right here. Oh, hold on a second. I made a mistake. What I should have done, I wasn't actually, it looked like it was always high, but that's not the case. My time slot was so low, I didn't actually see the signal that was happening. So I have a signal there that looks like that, and a signal there, and it still doesn't look right. So I set this board aside for the night, and I looked, and actually I was very interested to find, I re-looked at the LS74 data sheet, and found that actually there is a condition where both outputs will be high, and that's basically on a condition that really shouldn't be happening. Basically, if the clear inputs are both, I think it was low, and I went back and I looked, and I changed my time frame, and noticed that actually I did not have the signal that I thought. In fact, when I reduced the time frame, I got an actual signal on the chip. that shouldn't be happening. So I tracked down the places, and this should be just actually a pull. That line is just a pull-up resistor, so it should be it's a pull-up resistor, so it should be at +5, and it shouldn't be that at all. So I tracked down all the places where that, I made sure there's no jump or bridges, and I tracked down. It only goes to a few places, and one of them is this chip here, U65. I replaced it, or I pulled it. I haven't replaced it yet. Pulled it and tested it, and it shows an error. Now that's interesting because usually a chip, when it goes bad, the outputs will be bad, but sometimes when a chip fails, it can knock the inputs bad. And we do have an error. So and if I turn it on without that chip in there, high, and it is. And now let's see if our 74 is actually doing 8 and 9 should be the opposite. So here's 8, that's high, and low, that's low. Okay, great. So that's working, that part's working. Now, though, there's still something wrong because I don't have a picture on the screen. So we will get to that next. Oh, things still aren't working after replacing that, and I went to this chip. I followed things back to here because I followed the path of basically dead signals back to here, and now we have 8 and 9 working okay, but 2 of the controlling inputs are 11 and 12. So 8, 9, 10, 12 you have a signal, you can see, but 11 again dead. So we follow that back to this chip, U21, and that's output is 2, the input is 4, and you can see the output is dead. So we're going to go ahead and swap that out. So we swapped that one out, and that chip was already socketed, which is nice. And now let's check that output again. Output, what is it, 2? Yeah, it's 2, right? Well, now we have a signal there. Okay, but we still are dead. So, oh, and I'm running out of battery life. So I gotta cut this one off and go charge the battery on this camcorder.